This question, first of all, we have a curve. This is the curve. Curve. The name is C. And then there's a straight line L. Passes through the origin and is parallel to the tangent to C at this point. So let's picture this. First of all, we have a curve. So let's draw a very nice curve. Just randomly draw this one. Very nice curve. Okay? And this curve, the name is C. The equation is y equal to x times x minus 2 to the power of 1 over 3. And then we have a straight line L passes through the origin. Origin means 0, 0. And also parallel to the tangent to the curve at x equal to 3. So, I don't have a ruler here. Oh, too bad. I have to draw a straight line using hand. So, when x is equal to 3, say this is 3, the tangent of the curve. So it should look like this one. Okay, so this is the tangent of the curve when x is equal to 3. We know that this straight line L is parallel to this tangent, so they are parallel. This is the straight line L. And we also know that this straight line L passes through the origin, so it passes through 0, 0. Okay, so this is the situation, the picture. And now let's try to answer the question. Part A, we have to find the equation of L. Part A, find equation of L. L is a straight line. So to find the equation of a straight line, we need the point and also we need the slope, right? We need a point and a slope so that we could find equation of a straight line. Do we have the point? Yes, obviously, this line passes through the point 0, 0. So, no problem. Then what about the slope? Do we know the slope of this line? Yeah, because it is parallel to the tangent here. And for this line, the tangent, we know that the slope equals to differentiation of the curve when x is equal to 3. So the slope equal to dy dx when x is equal to 3. This is the slope. And since they parallel to each other, therefore the straight line L also has the same slope. Therefore, no problem, we could find the slope. Now, first of all, find dy dx. dy dx. Dy dx. Find this out so that you have to differentiate this. Oh, not that easy. Differentiate this, how could we differentiate this? It is a product. X times the brackets is a product. So let's use the product rule. Hold the first part, x, differentiate the second part. When we differentiate this, we have to use chain rule, bring the 1 over 3 down, copy the brackets, and then the index minus 1 becomes negative 2 over 3. And then we also need to times, differentiate the things inside the bracket. It becomes 1. Okay? Hold the first part, differentiate the second part. And then hold the second part, and then differentiate the first part. Differentiate x becomes 1, so that just times 1. Okay? So, let's rewrite this into a nicer way. X over, just bring this down, 3 times x minus 2 to the power of 2 over 3, and then plus x minus 2 to the power of 1 over 3. So if we have to differentiate this one more time to find the second derivative, you better combine these two terms together. But now it seems that we do not need to differentiate one more time, so I'll just leave it there. Now, we also need to put x equal to 3 to find the slope. Therefore, x equal to 3. That means we have 3 over 3 times 3 minus 2 to the power of 2 over 3 plus 3 minus 2 to the power of 1 over 3. 3 minus 2 become 1. 1 to the power anything, just still 1. So 3 divided by 3 become 1. We have 1. And here become 3 minus 2 become 1. 1 to the power anything also become 1. So that we have 1 plus 1. Oh, very nice. It becomes 2. Okay? So, don't forget that we have to find the equation of the straight line. We have the point. The point is the origin, 0, 0. And the slope is 2, become 2. So that let's use the point slope formula to find the equation. So first of all, we use y minus and then x minus, and then it becomes the slope. Y minus the y coordinate over x minus the x coordinate, and then becomes the slope, which is 2. So that we have y equals to 2x as the equation of L. Okay, so now here I could put it down. For L, the equation is y equals to 2x. This is part A. Now let's look at part B. We have to find the x coordinates of the two intersecting points of C and L. Oh, we know that C and L, the curve C and the straight line L, so they will come across each other. Maybe here, the line and the curve they meet, and here the line and the curve they will also meet at one point. So we have to find the two intersection points. So how could we find the intersection points of the line and the curve? How? Very simple. To find the intersection points, we just need to combine the two equations. First of all, for the straight line L, we have y equals to 2x. And then for the curve, we have y equals to x times x minus 2 to the power of 1 over 3. So these are the two equations. We just need to combine them, then we could find if there's any intersection points. So, how to combine them? On one hand, we have y equal to 2x. On the other hand, y equals to also this guy. So that means that these two things must be the same. So let's combine them. 2x equals to x times x minus 2 to the power of 1 over 3. Okay? And now, what do we do? What do we do to simplify this equation? We need to find the value of x, and there should be two values of x. So what makes us uncomfortable is the 1 over 3, right? So what could we do so that we could get rid of the 1 over 3? On both sides, what should we do? Yes, on both sides, let's give them a power to the power of 3. If we give the power of 3 to them, then here 3 give it to x to the power of 3, and 3 give it to 1 over 3 times them together become 1, so that we have x minus 2. And then the other side, it becomes 8x to the power of 3. Okay? And now, we should try to bring all the things together. 8x to the power of 3 minus x to the power of 3 times x minus 2 becomes 0. Right? So, what to do with these two terms? Any common factor? Yes, obviously, x to the power of 3. Bring it out, take it out. So that we have x minus x minus 2 equals to 0. That means x to the power of 3. So that becomes 8 minus x plus 2. So that we have 10 minus x equals to 0. Now something times something becomes 0. Either one of them must be equal to 0. So either x to the power 3 equal to 0 or 10 minus x equal to 0. And if x to the power 3 is equal to 0, x must be equal to 0. On the other side, we have x equal to 10. So that there are two values. There are two values of x. Therefore, we know that the line and the curve, they meet at 2 points, and these 2 points, the value of x is x and equal to 0 and x equal to 10. So we just need to find the x coordinates of the two intersection points. We do not need to find the y. Okay, done. Now what about part C? Find the area bounded by C and L. Find the area bounded by them, C and L. Area. Let's do it here. Part C. And we know that there are two situations. To find the area, we know that bounded by the two curves, we need to make sure that which one is on top, which one is on the bottom. First of all, if C is on top, the line is on the bottom, so that now we are considering x equal to 0 up to x equal to 10. Find this area. Then we have to use C minus L. But it could also be the line on top, the curve on the bottom. So x equal to 0, oh, they meet together. Oh, never mind. I'm sorry. Because they meet at 2 points, so what about this? Okay. So this is the curve. This is the straight line. They meet at x equal to 0 and x equal to 10. So this is the first situation. Or the second situation is that this is the curve, this is the line, the curve, the line, and they meet at these 2 points, equal to 0, x equal to 10. So we are looking for this area. So we need to find it out which one is the case. Should the curve be the one on top, or the line is the one on top? So how could we check? We just need to check the midpoint. So from 0 to 10, you just need to check x equal to 5. X equal to 5. You put x equal to 5 to the curve and also to the line, and then to check which one it should be the one on top. So when x equals to 5, for the line, we have y equal to 2x, right? So that y equal to 2 times 5 becomes 10. And for the curve, y equals to x times x minus 2 to the power of 3. So that when x is 5, we have 5 times 5 minus 2 to the power of 1 over 3. What should it be? 3, 5 minus 2 becomes 3 to the power of 1 over 3. And then times 5. Oh, it's 7.21. 7.21. So obviously, 10 is higher than 7.21. So this is the case. The line should be on top. The curve should be on bottom. Therefore, to find this area, what should I write? The area bounded by C and L, this is part C, should be integration from 0 to 10, and then the line 2x minus the curve x times x minus 2 to the power of 1 over 3 dx. So this is the way to find the bounded area. Okay? Next, we're going to integrate this. Are you confident to do this? First of all, let's separate them. The first part's just 2x. The second part, we have to deal with something very complicated, x times x minus 2 to the power of 1 over 3 dx. Okay? So, this part, we are happy to do this. Integrate this become 2x to the power of 2 divided by 2, so that's just x to the power of 2. And then consider the boundary from 0 to 10. So that, okay, next. Okay, what about this? It's not that easy, this part. So let's do this here. Integration from 0 to 10, x times x minus 2 to the power of 1 over 3 dx. What could we do to integrate this? Don't tell me product rule. There's no product rule in integration. Yes, we should let u be x minus 2. If u equals to x minus 2, then you have to consider du dx. Differentiate x minus 2 become 1, so that means du equal to dx. Okay? And then also, we have to consider the boundary. So when x is 0, then u equals to 0 minus 2, which is negative 2. And then the upper boundary, when x is 10, u equals to 10 minus 2 becomes 8. Okay? So that here it becomes from negative 2 to 8. And then we have x times u to the power of 1 over 3. And dx could be changed to du. But we have to make sure that all the things are in the same variable u, so that we have to change the x in terms of u. So let's look at here. If u equal to x minus 2, that means x equals to u plus 2. So that we could change x into u plus 2. U plus 2. And then times u to the power of 1 over 3 du. Okay? So now, next, this time we could just give the u to the power of 1 over 3 to everyone, so that we have negative 2 to 8, u to the power of 1 over 3. When they times together, we need to add the indexes up. So 1 plus 1 over 3 becomes 4 over 3. And then 2u to the power of 1 over 3, and then du. Okay? And now, integrate this will become just add the index by 1. So that 4 over 3 plus 1 becomes 7 over 3. So they become u to the power of 7 over 3 divided by 7 times 3. Plus, what about u to the power of 1 over 3? U to the power of 1 over 3, 1 over 3 plus 1 become 4 over 3. So that it become u to the power of 4 over 3 divided by 4 times 3. And also the 2 times 3 becomes 6. So that we have this. And the boundary is from negative 2 to 8. Okay? So let's copy this to here. Become 7u 7 over 3 divided by 7 plus, we could simplify 3 over 2. 3 u to the power of 4 over 3 divided by 2, boundary negative 2 and 8. Copy to here. Alright, let's go back to here now. So in terms of integration, it's done. Now, this is the parts that it is very easy to make mistake. So let's do it very carefully. First of all, we have to put 10 inside, so that we have 10 to the power of 2 minus put 0 inside, 0 to the power of 2. And then, okay, so this part, first of all, we put 8 inside, and the minus what we put negative 2 inside. So it becomes 3x to the power of 7 over 3 over 7 plus 3x to the power of 4 over 3 over 2. And then this time we have to put negative 2 inside as u, so that we have 3 negative 2 7 over 3 divided by 7 plus 3 negative 2 to the power of 4 over 3 divided by 2. And then, now, this is easy, just 100 minus, so let's use calculator to calculate this. Let's start from the most difficult part. So this part, 8 to the power of 7 over 3. And then times 3 divided by 7. And then plus, this result plus. Okay, so if you are very careless like me, I would like you should spend the time to copy down all the things, because it is very easy when we use calculators to calculate such a long stuff. 7,14286, okay, and then plus the second 8 to the power of 4 over 3 times 3 divided by 2 become 24. Okay, so the bracket minus and then this part negative 2 open brackets negative 2 to the power of 7 over 3 and then times 3 divided by 7. So it is negative 2.159864657. And then this part, open brackets negative 2 to the power of 4 divided by 3 times 3 divided by 2 plus 3.77976315. Okay, so this number minus 2.159864657 becomes 1.619898493, and then the previous part, it should be 54.8571428 plus 24. 78.8571428 okay, close brackets, and then 100 minus this 78 minus 1.619898493 becomes 77.2372447. Okay, and then times negative 1 become negative 77 something, and then plus 100, so it becomes 22.76275563. And finally, you need to give your answer in 4 decimal places. So you need to give your answer as 22.7628 correct to 4dp. Okay, so this is the area.